The cloud is not in the sky. It is in warehouses full of servers, chillers, batteries, switches, and backup generators. It sits on land, pulls from the grid, and needs water to stay cool. That matters because the debate around data centers is usually framed as if this is just a tech story. It is not. It is an infrastructure story. If a community hosts a data center, it is not just hosting software. It is hosting a new industrial load on its power system, its water system, and its local landscape. And the question in 2026 is no longer whether this industry is real. It is. The question is where the build-out is landing, what it is costing, and whether the people living nearby are getting enough back for what they are giving up. If they are not, then the boom is being subsidized somewhere else. Data centers exist because the modern internet needs a physical home. Cloud storage, streaming, search, banking, apps, and AI all depend on computing that has to happen somewhere. What changed is scale. Lawrence Berkeley National Laboratory estimates U.S. data centers used about 176 terawatt-hours of electricity in 2023, which was 4.4% of total U.S. electricity use. The same report projects a wide 2028 range of 325 to 580 terawatt-hours, or 6.7 to 12% of national electricity use. That is why this story suddenly feels bigger than it did a few years ago. The boom was already moving. AI shoved it into a much more energy-intensive phase. The U.S. Energy Information Administration now says data centers are one of the major drivers of rising electricity demand, and that is no longer a niche forecast. It is showing up in national load growth, in utility planning, and in the places where new power lines have to be built. The boom is national, but it is not evenly spread. Census data shows data center employment grew by more than 60% from 2016 to 2023. Yet more than 40% of that employment is concentrated in just 5 states: California, Texas, Florida, New York, and Georgia. Virginia is the most important single example. Northern Virginia is the largest data center market in the world, and the same region keeps attracting new development because it combines fiber, customer access, land, and power infrastructure. Other hotspots tell the same story in different ways. Ohio says it now has about 200 data centers, with most of them in central Ohio. Washington says most of the regulated facilities it sees are in Quincy and the Wenatchee area, because those places have dependable, lower-cost electricity. Oregon points to Eastern Oregon, where cheap land and power meet water limits and drought risk. Arizona is now forcing the issue through regulators and zoning. Texas is dealing with it through the grid. The pattern is simple. Data centers go where the utility map, land map, and policy map line up. The upside of a data center is easy to count. The downside is often distributed across systems. Start with the grid. Data centers push utilities to plan for new substations, new transmission, and sometimes new generation. In Virginia, JLARC says unconstrained data center demand would require a huge amount of new infrastructure and could drive up costs for other customers. Ohio's consumer advocate says transmission upgrades often get shared by all customers unless regulators draw a harder line. That is the hidden tax problem. If the project looks profitable on the developer's side, but the power system upgrade gets socialized across everyone else's bills, the community is not just hosting a building, it is subsidizing one. Then there is water. Cooling systems use water directly, and power plants use water indirectly. Oregon's own energy report says data centers are increasingly being built in eastern Oregon, where water is already limited, and drought conditions are common. That is where the ecosystem question gets sharper. It is not just about electricity. It is about rivers, wetlands, groundwater, and who gets access when demand rises. And then there is air. Washington's Ecology Department says the backup diesel generators used by data centers can create harmful pollution, which is why it reviews permits and tracks cumulative impacts. In Quincy, the state has even had to look directly at diesel particle exposure and local health risk. So when people say data centers are just buildings full of computers, they are skipping the part where those buildings change how a region uses power, water, and air. The story would be incomplete if we only talked about the costs. Data centers can bring real benefits. Virginia's JLARC study estimates the industry contributes 74,000 jobs and $9.1 billion in GDP annually to the state economy, mostly through construction and capital investment. Loudoun County says data centers generate almost half of its property tax revenues, and that revenue helps lower the residential tax burden. That is the strongest argument in favor of building them here. They can broaden the tax base, support construction work, and keep some places financially stronger than they would otherwise be. But the job story is not the whole story. A typical 250,000 square foot data center may have around 50 full-time workers, with construction sites bringing in far more workers temporarily than the finished facility keeps permanently. That is the trade-off in one sentence: huge capital footprint, modest ongoing staffing. So yes, these projects can benefit the places that host them. The hard question is whether those benefits are large enough, durable enough, and fairly distributed enough to justify the infrastructure they demand. This is why states are starting to intervene more directly. Arizona has opened a docket on how to protect ratepayers as data centers expand. Ohio lawmakers are proposing guardrails so grid upgrades do not get silently shifted onto everyone else. Washington is tightening emissions review. Virginia is debating zoning, water disclosure, and utility authority. The real policy question is not whether to welcome data centers or ban them. The real question is whether growth pays its own way. If a data center needs new transmission, new substations, more water capacity, and backup power rules, then those costs should be visible. If the project is a genuine economic win, it should be able to survive that transparency. That is the simplest standard. Make the energy use visible, make the water use visible, make the local impacts visible. Then decide whether the project still makes sense without hiding the subsidy. Data centers are not the enemy of the internet. They are the physical layer that makes the digital economy work. But that does not mean every data center should be approved, subsidized, or fast-tracked without conditions. If the country wants the benefits of AI, cloud computing, and digital infrastructure, it also has to be honest about the bill. The best question is not data centers or people. The best question is, what rules let America build the infrastructure it needs without making local communities pay twice, or disguising a subsidy as economic development?